Hey guys, welcome back. We got acids and bases and our calculations with them. All right, so we're going to start with strong acids, right, with and bases, where K is large, big K's. So we're going to think complete dissociation. All right, so when we have a monoprotic acid, so our strong acid, HA, the concentration of HA for a monoprotic acid equals the concentration of hydronium. All right, what do I mean? Think about it like if you had hydroiodic acid, HI. All right, if you had a 1.0 molar solution. All right, what we're going to assume is that we have 100%, or very, very close enough that we can't measure it otherwise, to get to H plus and I minus. So that means you would have 1.0 molar here, and we have 1.0 molar of I minus, which we don't care about. So the pH then is the negative log of H plus, which is the negative log of 1.0. So the pH is 0. All right, that'd be the pH. For monoprotic acids, that's what we got. Now, little note here. H2SO4. Only first H is strong, right, or 100%. Okay, only the first H. Now, for bases, concentration of base for strong bases equals your concentration of hydroxide. All right. So, for example, if I had KOH, and let's say we put solid KOH into water. No, I want H2O, and we're about 100%. Right, to K plus and hydroxide. So if we start off with 0.10 molar, we get 0.10 molar, which we don't care about. We get 0.10 molar hydroxide. So now, how do you calculate the pH here? Because we don't have H3O plus. Two ways, all right? Option 1, pH, well, let's do it this way. pKw equals pH plus pOH, right? So that means rearranging pH equals what? pKw minus pOH. So the pH would be equal to 14 minus the negative log of 0.1. So it means the pH would be 13. All right, that's one way to do it. The other way to do it is to know that H3O plus OH minus equals 1 times 10 to the negative 14th. So that means the concentration of hydronium equals 1 times 10 to the negative 14th divided by our hydroxide. So that means our concentration of hydronium is 1.0 times 10 to the negative 14th divided by 0.1. So that means our H3O plus concentration is 1 times 10 to the negative 13. And our pH would be negative log of 1 times 10 to the negative 13, which is 13. 0.0, because how sig fig works. All right. So those are the two ways to do it. Most students do it the first one. It doesn't matter to me. You guys have calculators. Calculators are great. And so that's that. I'm happy either way. So that's how we do strong. All right, and you can even shortcut this way, right? Because you have a calculator, you can do pH equals the negative log of 1 times 10 to negative 14 divided by 0.1. You could do that as well, right? So you can shortcut it with your calculator. I don't care how you do it. Either one's valid. So those are strong acids. Pretty straightforward, and a lot of times, when I'm in class for strong acids, draw a smiley face because the calculations, especially for the acid, really straightforward. Now let's talk about weak acids and bases. Where K is small. All right. So a lot of times this does get the sad face because there's always more calculations involved. All right. And so your weak acid, HA, doesn't matter what A is, plus water. You got hydronium. And you have your conjugate base A minus, whatever that anion is. All right. Ka for acid, all right, is equal to your concentration of hydronium, your concentration of A minus, all over concentration of your acid, right? And you have to use, if I could spell, use your ice tables that we learned in the previous chapter. Use ice tables for calculations. All right. And X, when you solve for X, that is the concentration of H3O plus most of the time, right? And so the pH typically is the negative log of X for monoprotic acids. These are for monoprotic. We'll do polyprotic later on. All right. Now, our current textbook talks about percent ionization as well. Which would be equal to your hydronium at equilibrium divided by your original concentration of acid times 100%. All right, so that's how you do the weak acid. So this is the acid, of course. All right, now base. Generic base B plus water. And we're going to get BH plus, the conjugate acid, and our hydroxide. All right. And we're going to have KB. And that's going to be equal to the concentration of BH plus, our hydroxide, all over concentration of base B. And again, we're going to use our ice tables for pH calculations. But note, X equals the concentration of hydroxide here. All right? So it's different than acids. So we have to do the extra steps just like we have to do for the bases up here. So you have to use same steps, right, as base. strong bases. Right? Which would mean like your pH equals 14 minus the POH, or hydronium equals 1 times 10 to the negative 14th all over concentration of hydroxide, right? So you got to do the same thing. All right? And so that is how we're going to calculate the pHs of strong and weak acids, strong and weak bases. If you have any questions, feel free to reach out. Otherwise, we'll see you in the next video.